Welcome to a video on operations and fractions.
When we are being asked to reduce or simplify a fraction, we want to divide out all the factors, the numerator, that's the top of the fraction, and the denominator, the bottom of the fraction, have in common. In this example, we will use prime factorization to help us. We are asked to simplify 36 over 84. We begin by finding the prime factorization of the numerator, that's 36. So let's write a small list of prime numbers. So the numerator is 36, and you begin. Out of these prime numbers, we start with the smallest. We start with 2. Can 36 be divided by 2? And it can. So we divide 36 by 2, and that's going to give us 18. Then we try it again. Can 18 also be divided by 2? And that's yes. 18 divided by 2 will give us a 9. And then we try it again. Can 9 be divided by 2? In this case, it cannot, because 9 divided by 2 will give us 4.5, so it can be divided evenly. So that means that we're going to move on from the 2 to the next prime number, and we're going to divide by 3. Can 9 be divided by 3? And that's yes. 9 divided by 3 is going to equal 3. And we stop because we notice that the result this time is another prime number. So that means that 36, the prime factorization will be 2 times 2 times 3 times 3. We take these values, the ones outside that upside down division. We're not going to follow the same process for the denominator. The denominator is an 84. So we begin by trying to divide by 2. And 84 divided by 2 is going to give us a 42. And then we try it again to divide by 2, and 42 divided by 2 is going to give us a 21. Now 21 cannot be divided evenly by 2. You get a 10.5, so we move to the next prime number. The next prime number here will be a 3, and 21 divided by 3 is going to be 7. And we stop here because a 7 is also a prime number. So that means that the prime factorization for 84 will be 2 times 2 times 3 times 7. Remember, those values are the ones that are outside of the upside division. Now that we have both prime factorizations for the numerator and the denominator, we're going to rewrite our original fraction. So that 36 over 84 is going to be rewritten 2 times 2 times 3 times 3. I'm using the prime factorization. And the 84 will be 2 times 2 times 3 times 7. And then we're going to see which of these prime numbers can be divided out. So in this case, 2 by 2, this 2 with this 2, 3 with a 3, and all I have left will be that 3 over 7. So that means for us that 36 over 84 is going to equal to 3 over 7. And this is a simplified form of 36 over 84. Let's try another example. We continue with prime factorization for this one. So let me rewrite the prime number list that we did on the previous page. We're going to take the same process. We're going to find the prime factorization of 21. So 21 cannot be divided by 2, if you remember. 21 divided by 2 gives us a 10.5. So we move to the next prime number. In this case, is 3. 21 can be divided by 3. The answer is 7. And we stop because 7, it's already a prime number. Then we try it again with the denominator. That's 42. So we start with the smallest of the prime. We start with 2. 42 divided by 2 will give us 21. As we saw before with the numerator, 21 cannot be divided by 2. So we move on to the next prime number, and that will be 3. And 21 divided by 3 will be 7. So then the prime factorization for 21 is 3 times 7, and the prime factorization for 42 is 2 times 3 times 7. So we rewrite our original fraction using the prime factorization that we found. So that's 3 times 7 for the numerator and 2 times 3 times 7 for the denominator. Now for this one, you're going to notice that we can eliminate the factor, the 3 with a 3, numerator with denominator, and then the 7 with a 7. The problem then becomes that there is no values left over in the numerator, but that's okay. When that happens, when you don't have any numbers left over, we're going to put a 1 on that. And then in the denominator, we do have a number left over. We have a factor of 2. So then this would be a 2 in the denominator. That means that 21 over 42 gets simplified into a half. We will now try a second method using a multiplication table to find the greatest common factor, the GCF. The GCF of a fraction is the largest number that can evenly divide both the numerator and the denominator. We're going to use the same fraction as example 1 so that you can see that we get the same answer. Now, you will also see that this method is faster than the prime factorization, and it will probably be the method you continue to use. But know that it has its limitations. We will go over the limitations after we complete the example. What we're going to do is we're going to find all the lines in the times tables where 36 and 84 live together. So let me show you the times tables down here. Remember, the numbers are 36 and 84. So I go through the lines and I notice that at line 2, 36 is there, but it's not long enough for me to see if 84 is also there. So I cannot use that one. Then I move on and I see that in line 3, 36 is there again, but it's not long enough for me to see if the 84 is there. The first time that I'm able to see both numbers is in line 4. So let's mark it here. In line 4, I'm able to see the 36 and the 84. Then I move on to 5. 36 and 84 are not there, but I see that in line 6, the 36 and the 84 is there. 36 and 84. I noticed that 9 has the 36 and it is long enough, but the 84 is not there. The next time that I see both of them is at the 12. So if I look at the 12, I see that the 36 and the 84 is there. The last line where I see the 36 is down here at the 18, but I notice that 84 is not there. So that means that the factors for 36 and 84 are 4, 6, and 12. Let's write that down. So the factors for 36 and 84 are 4, 6, and 12. But remember, we're looking for the greatest common factor. So that means the one that we're going to use to simplify this fraction is going to be the 12. So I'm going to divide both the numerator and the denominator by 12 to make the simplification. So 36 divided by 12 is 3, and then 84 divided by 12 is 7. Notice that this is the same answer that we got back when we did it in example 1 using the prime factorization. What will happen if you forget and you don't select the largest factor? Remember, the factors were 4, 6, and 12, and you forget and you don't select the 12. Let's say that you had divided by 6 instead, because 6 is your favorite number. So if we divide by 6, I get 36 divided by 6 is 6, and then 84 divided by 6 is 14. What happens is that this is not completely simplified, and the reason for that is because if you notice, 6 and 14 can be simplified again by 2. So what you're going to have to do is you're going to have to simplify more than one until you find that there is nothing else to simplify. In this case, I'm going to have to simplify by 2, and that's going to give me 3 over 7. Now, how do you know that you should stop? Well, you stop whenever you get this result. You see this 3 and 7, and you go back up to the multiplication table, and the only time that the 3 and 7 show up together is in the line 1. So if we decided to simplify by 1 or to divide by 1, you get back 3 over 7. So that's how you know that you could stop and that this is your final answer. Now, before we leave this example, let's talk about the limitations of this method. There is a limit as to how many numbers you can fit in one page for the times tables. As the numbers get bigger, we might run out of space and the numbers might not show up. So say that one of the values was 1125. Well, for me, the number is too big for it to show up in this multiplication table. This is why my recommendation is for you to also learn the first method, the one with the prime factorization. Let's try our first method using prime factorization to rewrite the fractions with the same denominator, known as the lowest common denominator, or LCD. We will then use the rule for adding and subtracting fractions with the same denominator to complete the process. So let's review the rule. To add and subtract fractions with a common denominator, we add or subtract the numerators and keep the denominator, and we cannot forget to simplify if possible. So let's do example 1 here. Example 1, we're going to begin by finding the prime factorization of denominators. So 6 will be 2 times 3, and 9 will be 3 times 3. So we rewrite, keeping the numerator and changing the denominator into its prime factorization. The reason for doing that is so that we can note which factors in the denominator are the same. In this case, both of these fractions have a 3 in common. However, notice how the second fraction has an extra 3, so we're going to multiply the first fraction, both top and bottom, by 3. And then we check that the first fraction has this 2 that the second one doesn't have, so we multiply both top and bottom by 2. So now we multiply all these numbers here. So I have 3 times 1 will be 3, and in the denominator will be 3 times 2 times 3, that will give us 18. On the second is 5 times 2, that will be 10, and in the denominator will be 3 times 3 times 2, that will be 18. Now that we have them with the same denominator, we can use the rule above. That means that we're going to add the numerators, so that will be 3 plus 10, and then keep the denominator, and that will be 18. So if we add 3 plus 10, that will be 13 over 18. For us, that means that 1 6 plus 5 9s is going to equal to 13 over 18. Let's try a second method using a multiplication table to help us find the LCD. Notice that we're going to do the same example 1 just to show that this second method gives us the same result as the first. So we're going to notice that the denominators for both of these fractions are 6 and 9. So we're going to go to a multiplication table and we're going to mark the line for the 6 and the 9. Here is 6 and here is 9. So what we're going to do is we're going to move through the line of the largest denominator, that's the 9, until we find the first value that is also on the 6, the other denominator. So let's begin. We notice 9 here is the first number in the line for 9. But 9 is not on the 6. So I move to the next number. In this case, is 18. So I check, is 18 the second number in the line for the 9 on the 6? And it is. So because the 18 is both on the 9 and on the 6, that becomes our LCD. Now notice that there's other numbers on the 9 that is also on the 6. For example, 36 is also on the 6. But the reason we're going to select the first one we see is because we want the least common denominator. That's the lowest of all the numbers that they could have in common. That means that we're going to change our fractions into a denominator of 18. Right here, 1 6, I want to change it into having a denominator of 18. And then 5 9s, I want to change it into having a denominator of 18. And the way we do that is we ask, what would I multiply this 6 to give me an 18? So I will have to multiply this 6 by 3 to give me an 18. So then I'm going to do the same thing to the numerator. So 1 times 3 will be 3. And then we do it again. What would I multiply the 9 to get me an 18? And that will be by 2. So I'm going to do the same thing for the numerator. And 5 times 2 will be 10. That means that 1 over 6 will change into 3 over 18. and 5 over 9 will be a 10 over 18. Notice that at this point, now we're matching the same thing that we got on the first method. So we just add 3 plus 10 over the 18. So this will become 1 over 6 plus 5 over 9 will be 13 over 18. Now you see that this method is faster than the first one, and it will probably be the method that you continue to use, but know that it has its limitations. There is a limit as to how many numbers you can fit in one page of the multiplication tables. Now, this one was fine because my denominators were 6 and 9, and there's enough space for me to have the 6 and 9. But if you have a denominator that is greater than 25, then you won't have enough lines to find the common denominator. Now, for me, it only goes to 25. You can find a bigger one if you like, but there's only so many numbers that we can fit into one page. So my recommendation is that you learn all three methods in this video so that you can move from one to the other if you can't particularly use this second method. Our third and last method is using cross multiplication. It does not require for us to find the LCD. While in the first two methods we didn't have to simplify, that doesn't mean that you will never have to. However, for this particular third method, at some point we will have to simplify the sum. We will be using one of the methods from the video on simplifying fractions to do this process. We begin by multiplying the denominators. So let's do that. I'm going to multiply 6 times 9, and that will give me a 54. The next step is I will have to multiply the first numerator times the second denominator, and that will become my first value up here. So that's a 9. Then I'm going to bring this addition sign because they're asking us to add, and then the next one is I'm going to multiply the first denominator times the second numerator, and that will be the last value that goes up here. In this case, it will be 30. Now, you have to be very careful. This is the most important step. You have to make sure that the multiplication is completed in this particular order. So, I'm going to bring down our result. This is 9 plus 30 over 54. So when I add 9 plus 30, that will give me 39 over 54. Now you might be saying, this is not the same answer that we got on the previous. Well, the reason why it's not the same answer is because, like I said, for this particular method, we are going to have to simplify our result. So we check what number can divide evenly both the 39 and the 54, and that is going to be 3. So both the 39 and the 54 can be divided evenly by 3. So when I do that, I get 13 over 18. And this is as far as we can simplify. That means that for us, again, 1/6 plus 5 over 9 is equal to 13 over 18, the same result as before. Two drawbacks for this method are that the values that we are going to have to simplify sometimes are going to get pretty big, and the other is that the order is extremely important. While the order might not be much of a difference in addition, it will make a huge difference for subtraction. So if you think about it, which is the best method? Well, that depends on you, on which method you think will be the easiest or the fastest for you to learn. We will start with multiplication. The steps for multiplication of fractions are to multiply across and simplify the result if possible. However, we're also allowed to simplify first using prime factorization. As long as we simplify a numerator with a denominator, the values do not have to be in the same fraction. If you haven't done so already, I recommend that you watch the videos for prime factorization and simplifying fractions first. So let's start with example 1. I'm going to do two different methods. The first one will be when I multiply first and then simplify, and the second when I simplify and then multiply. So let's begin. When I multiply 3/10 times 5/9, I'm going to multiply across. So 3 times 5 will give me 15. And then 10 times 9 will give me 90. The next thing is to take that result and find the greatest common factor. By this, it means we're looking for the largest number that can divide both the numerator and the denominator. In this case, both can be divided by 15. So 15 divided by 15 is 1, and 90 divided by 15 is going to be 6. What that means for us is that multiplying 3/10 times 5/9, the answer is 1/6. Let's now try method 2. What if we simplify first and then multiply? In order for us to be able to simplify, what we're going to have to do is we're going to have to find the prime factorizations of all the numerators and all the denominators. So since 3 and 5 are prime numbers, those will stay the same. However, the prime factorization for 10 is 2 times 5, and the prime factorization for 9 is 3 times 3. So then the 10 will be replaced with 2 times 5, and the 9 will be replaced with 3 times 3. Now remember, when we simplify, when I said at the beginning is that you can simplify a numerator with a denominator, and the values don't have to be in the same fraction. For us, this means that this 3 can be divided out or simplified with one of the 3's in the other fraction as long as it's a denominator. The next thing that we can simplify is the 5's, as long as we simplify a denominator with a numerator. Once we have that, we notice that there are no other factors to be divided out or simplified, so we just multiply the result. Notice how there are no values left in the numerator. When that happens, we place a 1. However, in the denominator, I have a 2 and a 3. Since we're multiplying, we're going to multiply that 2 times 3, and that gives me 6. Notice that for this method, 3/10 times 5/9 gives you the same result, 1/6. Now you can decide which of the two approaches is best for you. Division follows the same process as multiplication, with one step added at the beginning. We will call this step the KFC, which stands for keep, flip, and change. So this is how KFC works. We're going to keep the first fraction. We're going to flip the second fraction. This is called finding the reciprocal, and we're going to change the division to multiplication. All right, so let's start. We're going to keep the first fraction. We're going to flip or take the reciprocal of the second fraction, that's 12/7, and then we're going to change the division into multiplication. So from here, we take the same steps as multiplication. I personally prefer to multiply then simplify the result. If you decide to simplify before multiplying, make sure that you do the KFC first before trying to simplify your fraction. So let's multiply across. If I multiply 1 times 12, that's going to give me 12. And then 6 times 7, that's going to be 42. So I've done the multiplication part. Remember, once we get our result, we need to try and simplify. So the largest number that can divide both the 12 and the 42 is 6. This is known as the greatest common factor, or the GCF. So we divide both the numerator and the denominator by 6. So 12 divided by 6 will give me a 2, and 42 divided by 6 will give me a 7. What that means for us is that 1/6 divided by 7/12 is going to equal to 2/7.
Thank you so much for watching, and I'll see you in the next one.